Hi to all. Now the next topic in alternating current chapter. Today we are going to discuss AC voltage applied to inductor. Previously we discussed AC voltage applied to the resistor. Then we derived the formula for the instantaneous current through the resistor. Here this is the AC source symbol. This we are applying to the inductor. Inductor is nothing but a current carrying wire. Okay, a wire, an insulated copper wire wound like a coil, that is called as inductor. A inductor with a solenoid with large self-inductance is called as inductor. Okay, a solenoid with large self-inductance is called as inductor. L is the self-inductance of the inductor and I is the instantaneous current through the inductor. Now here the source applies the alternating voltage, that is V0 sin omega t, we are applying to the inductor of inductance L. Let us see here instantaneous voltage. Instantaneous voltage means voltage at any instant of time that is applied to inductor, or this we can write as AC source voltage, right? AC source voltage. What is that from the figure? That is AC source voltage is V is equal to V0 sin omega t. Every time it is fixed. This is equation 1. And where V0 is the peak value of voltage or the maximum value of voltage or the amplitude of voltage. Okay, amplitude of voltage. Peak value of voltage. Voltage we can also say that EMF. Okay, right. And then where omega is the angular frequency. Angular frequency of AC. Angular frequency of AC. And small t is the time. Small t is the time. Now let us see here. This one alternating voltage we are applying it here. L is the self-inductance. I want to derive the current at here. This alternating voltage, the voltage varies with the time. This voltage voltage value varies with the time. V is equal to V0 sin bracket omega t. Okay, now let us see here. At any instant of time, the current through the inductor we can take as L. But from figure we write one thing, that the applied voltage, this voltage across AC source equal to voltage across inductor. That what is the voltage across inductor? Is nothing but induced EMF across inductor. Right. This we can write as voltage across AC source is V0 sin omega t. That is equal to, what do you write? Tell me. V is equal to, we write as V0 sin omega t. It is equal to VL. VL is a voltage across inductance. V suffix L is a voltage across inductance. That we write as, we know, L di by dt. Yes, this is the induced EMF across inductor. Okay, voltage across inductor equal to induced EMF. That's formula is L di by dt. This we know already. Right. And now I want to write this one like this. L di by dt is equal to, what we write? V0 sin omega t we write. I want the di formula. Actually, finally I want to derive the formula for the current through the inductor. Then for that, di is equal to what you will get? Di is equal to V0 by L into sin omega t dt we will get. This is a small change in current through the inductor. And now total current I want. Integrate on both sides. Okay, integrate on both sides. On both sides. Then we will get the total current, instantaneous current. That is integration di is equal to integration V0 by L sin omega t dt we will get. Right? And here integration di is nothing but I. V0 by L we can keep outside, it's a constant. Then integration sin omega t dt. Then what is integration sin omega t? Integration sin omega t is minus cos omega t. Integration sin omega t formula is there in the mathematics. That is integration sin omega t dt is equal to minus cos omega t by omega. This is the formula. Then here we write substitute. Then we will get as minus cos omega t by omega we write. Here one thing we write, I is equal to V naught by L omega into minus cos omega t we write. This minus cos omega t we write as sin 90 minus omega t we write. 90 minus omega t. Sin 90 minus, because we know that the sin 90 minus theta is sin 90 minus theta we write as cos theta. According to that, cos omega t we write as sin 90 minus theta. But one more point we write, V naught by L omega we write as this one sin omega t minus 90 we write. Okay, right. This minus we can keep in inner side, then sin of minus 90 plus omega t, you will get omega t minus 90. Then this here we write, but L omega is the XL, X suffix L. It is called as inductive reactance. Inductive reactance means resistance offered by the inductor for the flow of AC. Okay, this is the inductive reactance, means resistance offered by the inductor. Resistance offered by inductor for the flow of AC. For the flow of AC, that is called as inductive reactance. This is substitute in above equation. Then we will get I is equal to V naught by XL into sin omega t minus 90 we will get. This equation we write like this. This V naught by XL we can consider as I naught. Then the final equation we will get as I is equal to I naught sin omega t minus 90 we will get. This is the instantaneous current. This is equation 2. Okay. Here instantaneous voltage is V is equal to V naught sin omega t. Instantaneous current is I equal to I naught sin omega t minus 90. This we can consider as voltage by resistance. It is the peak value of current, that is I naught, I suffix 0. Okay, right. Now you take the screenshot and note every point. Okay, now in this you take the screenshot and note every point, and I will continue after the rubbing. Okay, now let us continue. We are discussing the AC through inductor. We derived the instantaneous current formula, right? Instantaneous voltage formula. From equation 1 and 2, what we write? From equation 1 and equation 2, we have the equations, that is V is equal to instantaneous voltage, AC source voltage. V is equal to, we have V naught sin omega t. Voltage angle is omega t. From equation 2, the current formula is I naught sin omega t minus 90. Right? Okay. Then what is the phase difference between the voltage and current? Voltage angle is omega t, current angle is omega t minus 90. Okay, then we write like this, the phase difference between current and voltage when AC voltage applied to inductor, what is it? The phase difference means angle difference. We have to find the difference. that is omega t minus omega t minus 90. Then we will get the phase difference as 90 degree. That is means the angle between the current and voltage is 90 degree. The angle between current and voltage in phasor diagram is 90 degree. Okay, let us draw the phasor diagram, and in this the current angle is less and voltage angle is more, because if you add 90 for the current angle, we are getting the voltage. For example, voltage angle is omega t at here, that is we can take as 120. Then the current angle is omega t minus 90. Voltage angle is omega t, current angle is omega t minus 90. That means the current angle is less, only 30 degree. Right? The current angle is 30, voltage angle is 120. I am considering that the voltage angle is 120, omega t is 120. Then the current angle is omega t minus 90. That means 120 minus 90, that we will get 30. The current angle is less and voltage angle is more. Right? Let us draw how to draw the phasor diagram for this. Right? Let us see here. Phasor diagram. Phasor diagram. Okay? Yes. Let us see here. In the phasor diagram, right? Okay, we draw like this. Okay, and this is x-axis and y-axis. We take the, for example, the voltage will rotates by an angle omega t. This is the voltage. The angle is omega t. Voltage angle is omega t. What about the current angle? Current angle is omega t minus 90. Current angle is omega t minus 90. Then we can express like this. That is, I will take the voltage angle in the different way. For example, voltage across inductance is this side. Okay, voltage across inductance. This is the voltage. That is the voltage across inductance. V is equal to VL is this side. Okay. And this angle we can take as omega t total. This total angle is we can take as omega t. Anything you can take as omega t angle, right? From here to here it is rotated in anti-clockwise, it is rotating, right? This total angle is omega t. This angle. Now what about the current angle? The current angle will be like this there. The current will be like this there. This is the current. What is the angle of current? Right? What is the angle of the current? The angle of the current is omega t minus 90, right? And this angle is, current angle is omega t minus 90 and voltage angle is omega t, right? Like this we can indicate as rotating vectors. Okay, right? In this you see here from the example, for example, current angle is rotated by 30 degree. Current angle is rotated by 30. Then what about voltage angle? 120. That means it will be rotated 30 current, but the voltage is 30 plus 90, right? Total 120. This is 90. Angle between the voltage and current is 90 degree. This we can also express like this, or simply I will draw. And here we draw like this. This is the current. Okay. And this is the voltage across inductance. Two are taken as rotating vectors, but the current angle should be less, current length should be less, right? We have to take the current length as less. This is the current, and we are taking them as rotating vectors. Okay, they are rotating in the anti-clockwise direction like this. And now the angle between the voltage and current is 90 degree. But this is the phase difference. They are rotating, right, in the anti-clockwise direction. Current is back of the voltage. Current is back of the voltage. Current is rotated by 30 degree, but voltage rotated by 120 degree. That means the current is in lagging comparing with the voltage. That means we write like this from the phasor diagram. Okay, we write important point, this one, that is current lags, current lags voltage or EMF, current lags voltage by 90 degree in inductor. This same thing we write like this. Current lags means current angle is less comparing with voltage angle. And then we write this one like this. The voltage leads. Voltage across inductor leads current by 90 degree in inductor. Right? Current lags or voltage leads. Current is back of the voltage by 90 degree or voltage is front of the current by 90 degree, right? When they are rotating like this, in anti-clockwise direction they are rotating. We have to see in anti-clockwise direction, like this they are rotating. This is the current and this is the voltage, right? Now the current is back of the voltage. They are rotating like this. The voltage is rotating forward and the current is back. Then like this they are, current is lagging the voltage by 90 degree or the voltage is leading the current by 90 degree, right, in the inductor. Voltage leads current by 90 degree in the inductor. Let us draw the graph. One graph I am going to draw, that is VRI versus time graph I am going to draw, right? I will take time on x-axis, okay? I will take the time on x-axis. Time on x-axis. And voltage, time on x-axis and the voltage on y-axis. Voltage or EMF or current is taken on y-axis. Let us draw the graph, how it will be there. Let us take this one. And now here the voltage or current on y-axis. First voltage graph we draw. It was very simple. The voltage graph is always same. That is V is equal to V naught sin omega t. This is the V is equal to V naught sin omega t. Okay? Right. What about the current graph? In this peak value of voltage is what? The peak value of voltage is V naught. And what about the current graph? The current graph will be like this there. That is current is this one, I equal to I naught sin omega t minus 90. If you write t as 0, then current sin 0 minus 90 minus sin 90, sin of minus 90, time 0 you take. It's here when time 0, voltage 0 we will get. When you write t as 0 in this equation, V0 you will get. But when this you write t as 0 in this, then current what you will get, sin of 0 minus 90, sin minus 90, minus sin 90, that is minus 1 you will get, minus 1 into I naught, minus I naught you will get. That means it will start from the, when time 0, time is taken on x-axis, right? When time 0, we will get the negative value, that is the minus I naught we will get. Then after that it will start to decrease like this, and then after that it will go like this. This is the current equation. That is I is equal to I naught sin omega t minus 90, right? Here the peak value is minus I naught. Then one important point I will give, that is what is the peak value of current in the inductor, right? Peak value of current, peak or value of current or amplitude of current, amplitude of current in inductor. Yes, what is that? That is the current I naught is equal to voltage by resistance. But what is the resistance of the inductor? That is XL, right? V naught by XL. XL is L omega, right? This is the formula for the peak value of current. Peak value of current. Okay? Note every point. Thank you for watching my lectures.